Lesson 1-2, Order of Operations and Evaluating Expressions. All right, hopefully you see something on the screen that looks familiar to you. PEMDAS, P-E-M-D-A-S, are what we usually refer to remembering our order of operations. So this lesson should also be a review or something you've seen before. All right, notice though, I have the word PEMDAS. I've added this R. Take a second and pause your video and see if you can remember what every letter stands for minus the R. All right, to review, P stands for parentheses or grouping symbols. E is for exponents. This R stands for radicals. A radical is like a square root sign, much like this image here. A little further with radicals, when you have a square root sign and an exponent, they actually cancel out. So this image right here is saying I love math. Pretty cool. So R is for radicals. We're going to add that one in this year. M is for multiplying, D is for division, A is for addition, and S is for subtraction. So we'll need to use these for this lesson. All right, before we get into our PEMDAS or our PEMDAS, we're going to talk a little bit about exponents or powers. All right, so we use powers to shorten how we represent repeated multiplication. Instead of writing 2 times 2 times 2 times 2, we can use an exponent to simplify that. Now a power has two parts. It's important to know this. This whole thing right here is the power, 2 to the third power. That's the power. There's two parts. There's the base, which is the 2, and the exponent, which is 3. Okay, so that exponent can change. It could say 2, 3, 4, 5, and so could that base. To simplify a numerical expression, when you replace it with its single numerical value. So what this means is instead of writing 2 to the third, we can simplify. We know that that means 2 times 2 times 2. So we're going to simplify powers. So 10 to the 7th is like 10 being multiplied 7 times. Just like 0.2, that decimal, to the 5th power is like multiplying 0.2 5 times. All right, so pretty easy. But then to finally simplify it, we actually do that multiplication. For example A, we get 10 million. And for example B, we get 0.00032. Okay, so that's the final simplified form. So, what is the simplified form of each expression? 3 to the 4th is 3 being multiplied 4 times. Then you can use your calculator to figure out what that is. 3 times 3 times 3 times 3 is 81. 2/5 to the third power, nothing changes. 2/5 written 3 times. When you do that multiplication, you actually get 8/27. Again, you can use your calculator. And C looks similar to B, so I'm going to skip that one. So that is simplifying powers. Now, when you're simplifying an expression, we need to perform operations in the correct order. That's where our PEMDAS come into play. So, for example, if we had this expression, I see a lot of operations. If we get 25, that's the wrong answer. That means we added first, and we know that with PEMDAS, we have to multiply first to get the correct answer. So it's very tricky. If you don't do it in the right order, you get a different answer. All right, so this key concept is really important to note. Perform any operations inside grouping symbols and brackets. A fraction bar also counts as a grouping symbol. That might be new to remember. Second step, you want to simplify powers. And then multiplication and division, you don't have to do one before the other. You just do it from left to right, whatever comes first. Same with addition and subtraction, left to right. All right, let's look at some examples. So we're going to simplify a numerical expression. So I see 6 minus 2 in a grouping symbol. It's raised to the third power and divided by 2. 6 minus 2 is 4. 4 raised to the third power is 64. Divide by 2 is 32. All right, here's where they mean a fraction bar also acts as a grouping symbol. 2 to the 4th power minus 1 over 5. So you want to simplify the power first. 2 to the 4th is 16. 16 minus 1, we want to do that subtraction first, 15. Then we can divide and we get 3. All right, let's do another example together. We'll do A. 5 times 7 minus 4 squared divided by 2. I see an exponent that I want to do first. So I'm going to rewrite this. 5 times 7 minus, well, 4 squared is 16. And then divided by 2. I have multiplication, subtraction, division. I'm going to do my multiplying first, so that's 35. 16 divided by 2, I have to do division first, so that's 8. 35 minus 8 is 27. So really important to remember those order of operations. All right, we can evaluate an algebraic expression by replacing each variable with a given number, and they will give you those numbers. So, for example, evaluate these expressions when x is 5 and y is 2. So here's the expression. Wherever you see a x, put in a 5. So I would rewrite the entire problem. Oh, they did it right here. Rewrite the entire problem with 5s in for all the x's and 2's in for all the y's. Then do as you would with order of operations. All right, so let me do a problem for you. We'll do A together. Oops. 3b minus a squared. Well, b is 4, so it's 3 times 4 minus a squared. A is 3, so minus 3 squared. So parentheses, 3 times 4 is 12. 3 squared is 9. 12 minus 9 is 3. Sometimes we have to evaluate a real-world situation or expression. So in this example, you have spending money left over after you put some money away into savings. So let's see. We want to come up with an expression for the amount of money you have left after you put money into savings. So if we look at this little chart here, we want to know how much spending money we're going to have. And it all depends on how much we make for our wages each week. So they've given us some values that they want us to plug in and find out how much spending money. Well, first let's get an expression going. If I define W as my wages, whatever I make each week, if I take my wages, and it says in our example that every week we deposit 2/5 of your wages. So if I start with my wages and I take away 2/5 of those wages, or 2/5 times W, that should give me my spending money. So this expression is what's right in the middle of our chart. Now, depending on what our wages are, the spending money changes. So they just want to know, can you write this expression and can you use it to find multiple values? All right, that ends our lesson on order of operations. So please complete the lesson check 1 through 7 and bring your notes and these answers to class.